Hey there, everyone. This lesson is on how to find the units for K, and we're going to use the rate law equation to do that. So excuse the general crumminess of the video. I am deep in the snow bunker today, so I don't have my usual bag of tricks, but we'll make the best. So let's draw a rate law equation and then substitute in the units for each of the components, and then solve it for K, and then we'll see what the units of K are. It actually changes depending on the order of the reaction. So let's just take a second order rate law equation. So we could say that R is equal to K times the concentration of, let's just say we have some NO to the second. So you know it's second order. Now, rate is a change in concentration over a change in time. So we know that rate is delta concentration over delta T. So if you ever see some big long explanation of that, this really just means rate. But we know in the numerator here that concentration is going to be in molarity, and time could be like minutes or seconds or hours, something like that. So as an example, we will say that it's going to be a change in molarity per second. So those are the units for R. We want to find the units for K, and then the units for concentration are always moles per liter, which is molarity. Now, since it's squared, we could have written that like NO to the first times NO to the first again, which would mean we would have a molarity times a molarity. So we can write it that way here, or we can write molarity squared. Now, when we solve this for K, we're going to divide both sides by these two molarities, which means over here, they go in the denominator as well. And so you can see that these cancel out, and K is going to be, after we cancel out one of the molarities, 1 over molarity times seconds, which is kind of gross as far as the units go. Now, there's a couple different ways you can represent that. Remember, algebraically, whenever you don't feel like putting things in the denominator, even though that's where they are, you could also just write it as to the negative 1 power. So I could say molarity to the negative 1 seconds to the negative 1. That's the same thing. We could also say that molarity is actually just moles per liter. And so if we have 1 over molarity, that's just the inverse of this, which would be liters over moles. So I could write 1 over molarity down here as liters over moles. Sorry, that should be lowercase. Times seconds. Liters over moles times seconds. If you want to be really crazy with it, you could say liters times moles to the minus 1 times seconds to the minus 1. But that's just getting a little silly. So we have this 1 over molarity times seconds, and that's if it is second order. So let's just keep track of it here. We got 0, first, second, third. Scratch that. We're not going to have a 0 order. So for second, it was value for K, that is 1 over molarity times the time which we decided we were going to use as seconds. You will have to look at the specific case for the problem that you're looking at. So let's go now and look at one that's first order. If we say R equals K, something to the first, we're still going to have molarity per second for R. And then this time we're only going to have 1 molarity because it's just 1 concentration. So when I solve for K, you'll notice again that a molarity cancels out on both sides. And this time, all we have left is 1 over seconds. So K is just 1 over seconds for first order. If we have third order, let's say we have our NO squared and our O2 to the first. And there's our rate law. 1 and 2 makes 3, third order overall. Now we have molarity per second. And that's equal to K. And now it's molarity squared times molarity. Solving for K again, we're going to divide both sides by all the molarities. Molarity squared times molarity. And so K will be, let's see, these cancel. We have a molarity squared on the bottom now. So 1 over molarity squared times seconds. So hopefully you're starting to see a little pattern, which is what I want you to see, so that it's easier to remember and easier to solve for or calculate yourself, or easier to just memorize. So if you take a look, the number of molarities in the units for K is always 1 less than the order. So if it's second order overall, there's only 1 molarity. If it's third order overall, there's 2 molarities. If it's first order overall, then there's none molarities. So it's always 1 less than the overall order of the reaction. So if you substitute in molarities and molarity per time for the rate and then solve for K, you can get it. These are really the only 3 choices. So it's always going to come down to one of these. So for memorization, not super hard, but also not that difficult to just substitute in the units for each and then solve for the units of K. Hopefully that helps and you can use that with your practice problems. Have fun.